Everybody's okay with this one? I did all the points out for you, so everybody's good. There's no questions? Okay. All right, this one. So we had, again, when frequency is 1, that's not so bad, because you're still following your regular pattern. Everybody's okay with this one too?
Yeah, I'm just checking the numbers.
Yeah, please check them, because that makes a big difference.
Wait. Why did you go? Oh, never mind. Negatives.
This is passing through the -2. It just, I missed the point.
Yeah. Okay. I forgot. I didn't write down the
Reflect it?
negative. Yeah, I didn't write down the negative when I copied.
Oh, okay. All right. So yours is the same, but the opposite way.
Yeah.
Yeah.
Okay.
No questions. God bless. Okay. Phase shift. Make sure you start at where your phase shift starts.
Oh, I didn't get this.
Yeah.
Okay. So phase shift. So first thing we look at is this part right here. This is going to start. Technically, we have no start and stop. It's a continuous curve. But for our purposes, we do have to start somewhere because there's a difference where unless I do this, or if I started here, and then it would go here and do this. So there's a difference where we start. So we look for a full cycle. And normally our full cycle is between 0 and 2 pi. This is our first full cycle because it's technically around our 4 quadrants. A phase shift is going to move that starting point. So set it equal to 0, set it equal to 2 pi. So now your cycle goes from negative pi to positive pi. You have to start your cycle at the negative pi. If you started it at the 0, the whole curve is in the wrong position. So technically you have to start it right here. And then you follow the same pattern. Everything else is the same. My frequency was 1. Today we're going to change the frequency. My frequency was 1, so I'm still looking at my 4 quadrants. I multiplied it by a -1. This reflected it. It didn't change my amplitude. Then I subtracted 2. This did a vertical shift down. And I started with these points. Same thing as you've been doing. The only difference is, where do I start? I don't start at 0. I start at negative pi. If you started at 0, then this guy would start down here. Now, do you have your calculators handy?
Yeah,
Let's do this on your calculator as well. Sorry, you with me here? Got a calculator? Get it out. Come on. There's no reason why you guys didn't get that. We did a bunch of those. All right, so we're going to put this in. I'm going to try to put it in. Use X for theta. And we're going to have to make sure what's our mode going to have to be in? Radians. Okay, make sure your mode is in radians. Make sure you do a zoom trig. Zoom 7. Make sure you do a zoom 7. Now, you should be fine with this because we didn't change. Your frequency is still 1. So your scale should say, if your frequency is 1 and your period is 2 pi, it takes you 2 pi no matter where you start to complete a full curve. Your increments, your quadrants, your 4 quadrants are 2 pi divided by 4. So pi over 2. So in your table set, when you want to look at your table, you're going to start it at 0 and you're going to make it match your graph. And you're going to put pi over 2. Okay, and now when you look at your table, you should see these values. Now, the easiest way to do these, because they are in radians, is just to follow your graph. You made these go every 90 degrees. So at the 0, you're here at -1. At the 90, that's the next guy. You're at -2. Isn't that pi, 3.14? You're -3. And then, if you want, just go to the negative side. As long as you increment your table to wherever your graph is incremented, it doesn't matter that your radians are all decimals. It'll follow one right after the other. You'll see your pattern. Don't we see our pattern here? That's what you're looking for.
Well, like on the test, will we ever get rid of structure?
Probably not. Probably not. You'll probably do a part without calculators and a part with.
I just want to know so I
You don't
can
need
check
a
my
calculator, right?
You don't need a calculator for this, but what I'm saying is if you want to check it, the only thing, the difference is your table, is your scale. Scale your graph and your table to whatever your increments are, and then they'll fall right into place.
Can you go to the water source real quick? Just want to make sure mine's the same because I found this in the earlier. It's just negative cosine in parentheses x plus pi, right?
Yes, -2.
Mine's
Is your mode in radians?
Yeah. Mine looks like someone's having a heart
Did you hit Zoom 7? Oh, you're getting all those little lines? Did you hit Zoom 7?
Yeah.
Oh, yeah, so you don't.
You know what happened? You changed your mode, right? You graphed it the first time. So as soon as you change your mode, you gotta Zoom 7 again.
Oh, okay.
Yeah. If you change your mode, if you graph and then you change your mode, you have to re-Zoom 7 because your calculator has to recalibrate it. All right, so then the last one was another phase shift. And again, I left your frequency 1.
Oh, no, that right.
Okay, so we shifted this to the right. So we're going to start at pi over 2. We shifted it 90 degrees to the right, pi over 2 units to the right. So this is where we're going to start. This is our starting point for your sequence of numbers.
Fine, we'll do it. Can you more?
Yes.
If you add one, wouldn't the 0 be 1 then? Maybe 1 to be 1.
1, 3, 1. Yeah. Yep.
What is that number that's
So here.
0,
Sorry.
1, 0, maybe?
I got it. Yeah, I got it over here.
What is that?
Well, this is your cycle of sine. It goes through your quadrants. This is so that you don't need any, whatever you're comfortable with graphing this, but if you're going to walk through your quadrants, you're walking through your max, your mins, and your zeros. So sine, all your other numbers are in between. Well, we amplified this, so it's a little harder to tell. We changed your amplitude. But on a normal circle, all your signs are in between 0 and 1, right? Isn't your range from -1 to 1? So these guys are your mins, your maxes, and your zeros. So if we just graphed your sine curve, we start here. This is 0, the y is the sine, 90 is a 1, 180 is a 0, 270, -1, 0. We're just graphing off your quadrants. It gives you your maxes, your zeros, and your mins. That's all you need to graph from. We don't need all these little angles in here. Especially us, we're just sketching. So if you change, an easier way to figure out where your pattern is, take it one step at a time. I'm going to multiply this by 2. I'm changing my amplitude. Instead of going to 1, I'm going to 2. So multiply everything by 2. You're shifting it up. Add 1 to everybody. And that's your pattern. And that's where you'll start. And the only bad part about this was you had a phase shift, so you couldn't start at your 0. You had to start here. You had to start where your phase is. Everybody can do this part, right? This is the most important part of this whole thing. Right there. That's where your cycle starts. Guys, could I kind of have everybody's attention here?
I was just helping.
Oh, okay, go ahead. So that's where your phase is. Normally, where's your cycle? From 0 to 2 pi. If you've shifted this, it's not going to start at the 0. When I go to make my sine curve, my basic sine curve, it's a continuous curve, but why don't I start here and make my sine curve? Why don't I start here and make my sine curve? Because it's not at the 0. Because normally we start at the 0 and we follow your pattern. This says, uh-oh, shift this over. Don't start until you hit pi over 2. So at pi over 2, here's my cycle.
Oh, that's why I kept getting.
Yeah, you can't start at the 0. You got to start. This is the most critical part right here. Find where your cycle starts.
What I was trying to do is I was trying to take the original, and then I would go to the pi over 2, and then take the point that was at pi over 2 and bring it to the 0, which is not
The opposite way.
Yeah.
So the 0 of the original is a pi over 2. Okay, so today we're going to add another little phase shift in there
Oh,
when the frequency is not 1. And we're also going to write a few equations.
we're gonna write them
We're going to write some equations.
like when we're taking the graph.
Like in the graph, write the equation. But normally we do that without a phase shift because otherwise you have to go crazy trying to figure out
Yeah.
is it just a reflection, is it just a... I just call it
Bracelet.
I don't know, I'm not sure.
Yeah.
No, I feel it, but I know I'm not gonna go study over this. Yeah. No, I'm gonna actually go. I'm gonna try to finish up finishing. I'm hoping that they're gonna find a location for me, but I don't know. I'm my best help. My reading code is so low. Randomly, my English score will be like a 33, and then I'll be like 20.
Where did you know that?
Creative class, what? I thought my English score was going to be consistent, and then all of a sudden, they're recording. People are like, no, we're not.
Alright, so see if you can take the first one and find the equation. Guys, see if you can find the equation of the first one.
Found the equation.
Find the equation for the first one. Actually, what'd you get?
Cosine x plus 2 or theta plus 2.
Plus 2? Okay, do we agree?
Yeah. Can you explain how you got plus 2?
Okay, so find the resting point. You know how this is a cosine. How did you know this was a cosine curve?
It doesn't start at 0.
It didn't start at 0. It went up, right? It went up first. So cosine comes up here, comes back down. It has a resting line, or as the other sheet called it, a midline. It's equidistant from the top to the bottom. So just count. 1, 2, 3, 4, 5, 6. What's half of 6? 3. So either come down 3 or go up 3. Here's your midline, your resting line. Normally this is our resting line right here, the y equals 0. Where did we move to? Y equals 2. We moved up 2. That's this guy right here. And now you can tell your amplitude a little bit better. What's our amplitude?
3.
3. Okay, so we knew it was a cosine curve. We identified the cosine curve because we said it moved up. It could be a sine curve shifted, but I'm not going to do that to you. I mean, if you came up with a phase shift in it and it works, that's fine. There's more than one way to name this. But we'll just go for like the basic curve. So find your midline, your resting line, and that's where you see your shift. That's the easiest way to find that one. Okay. Try this one. Okay, hang on, I'm going to come right to you.
I got it.
You got it too? Okay, let's see what you got.
I got it. What? I was totally not listening.
Yes.
Uh,
Okay, so we know this is a cosine curve, not only because of the directions told us we were cosine,
yeah.
but how do we know this is a cosine curve?
It started at least.
There's no.
It didn't start at the 0, but it didn't go up either. Where did it go?
It went straight down.
It went down. So what does that give us when it starts down first?
That's called a reflection.
A reflection. So we've got a reflection in your x-axis going on here as well.
Couldn't there have been a sign if you just shifted down?
You can do a shift. If you want to do a phase shift, no, not a vertical shift, no. Because wherever you're resting, where's your resting line here? It's at 3, at -2. So your sine curve would have had to start at 0. If you did a phase shift, you could use a sine. Your sine starts at 0. Your cosine starts at 1. Well, actually, this one is reflected, so.
But what if you shifted it up like 7?
If I shifted it up 7, yeah, but it still has a resting line. It's still, the first part is still dropping down. No matter where you move your cosine curve, your 0 still either goes up or down. It didn't start at the midline. Your sine is going to start right here at the resting line. Your cosine isn't. So wherever you shift this to, is unless you shift right or left.
Oh, I see.
Yeah. Unless you shift right or left, that's different. So if you shifted this 90 degrees over, then you have a sine curve, right? I can do that, but since the direction said cosine, we stuck with cosine. So we know we have a reflection. What's your amplitude? 3. And we said we have the reflection. We know it's a cosine. Now, here's 2 pi. So I've got 1, 2, just 2. So 2 theta. And where did I shift this to? -2.
A question out of curiosity. Why do we use theta and trig and not x?
Because x really represents like a number variable. Theta represents an angle. You can use x. It's still a variable. You can use x, but technically we use it as an angle.
Why is there something again?
Why is there 2? Because this is your frequency. This tells you how many complete cycles in 2 pi. So when I start here, I go, this is 1, this is another one,
Oh, okay.
2. Okay, so now we're going to do a little bit more with phase shifts.
Oh boy.
Okay. The first one, basic phase shift. I didn't change the frequency. I didn't change the amplitude. I just shifted it over, which you guys been doing when b is equal to 1. So which way is this going to transform to? We're going to do what? I'm sorry? To the left, to the left. Okay, so we're going to do a horizontal shift. Left pi over 2 units. So now, my normal cycle goes from 0 to 2 pi. It's a sine curve. I have to shift this. I have to start at -pi over 2. Doesn't that make sense? If I'm going to move it to the left. So the best way to do this, yes, I know you can eyeball this, but the best way to do this, God bless you, is to set this equal to 0, because we start at the 0, and to set this equal to 2 pi over to 2 pi. Because we want to see where is this going to go. Where is one complete cycle going to go? So again, if I subtract pi over 2, what do I have to do to subtract 2 pi minus pi over 2?
You have to make it 4 pi over 2.
Make it 4 pi over 2, common denominator.
Wait, I have a question.
Yep.
Why don't you just draw the original one and then just move it over one?
Because it is so simple when we do that. But it is not so simple when I'm going to change b on you. So I want you to follow the same pattern, because when you look at it this way, don't you understand it, right? You understand it, why can't I just shift it over? So you do see that your phase shift doesn't start at 0, it starts somewhere else. But in the next one, I'm going to change b on you.
The frequency?
B is your frequency. So that's going to make it not as obvious. Now I can't just say, oh, this is moving pi over 2. It's not going to move pi over 2. So what you do for a pattern here, you're going to do the same thing here. So yes, I know we've done these. So I brought this back because you're comfortable with it and you do see it. Why can't I just go to pi over 2? And negative. And I absolutely can. So again, you're going to start at your negative pi over 2. Did we change your amplitude?
Nope.
No. So when you're here, 0, 1, 0, negative 1, 0, 1, and you just keep doing your cycle and just work it backwards until you finish. Okay? And that makes sense. We took your sine curve and we shifted it over. We made it look like a cosine curve because your quadrants are 90 degrees apart. So sine and cosine, if you remember, even way back when we first did that chart and we looked at the cofunctions, the sine of 30 was the same as the cosine of 60. Remember the cofunctions? So that's why this works like that. Now this guy works a little bit different. He works a little different. I now I'm almost the same, but I now changed your frequency. It almost looks the same, doesn't it? But I changed your frequency. So the amplitude is still 1. I'm still following my sine curve. However, now when I do C over B, which way am I moving towards?
Move to the left.
Left. Now I got to do C over B. This is C. This is B. Pi over 2 over 2. How does that come out to be? Flip this. Use your rules. Keep. Change. Flip. Pi over 4. If I cut 90 degrees in half, what does it come out to be? 45. Okay. Now it's the same thing we just did. Only thing is I just changed your B. So now. Yeah, but so think of it logically. It's still shifting, but now instead of going 90 degrees to the left, I got 2 cycles. So don't I have to put 2 of these things in the same place?
Yeah.
So don't I take half the period? Aren't I taking half the period? So shouldn't I take half of that space? I should start at the 45. So now I'm going to follow my rule. I'm going to set this equal to 0, and I'm going to set this equal to 2 pi. And yeah, we can still figure out here where we're going to start. We can kind of visualize this. So we do this. We divide by 2. And yep, you told me exactly we were starting at negative pi over 4. We shifted it to the left. We got 2 cycles to go through. So we're going to do this. So we're going to subtract pi over 2, which is 4 pi over 2, right? And divide by 2. So we're going to go to 3 pi over 4. So our full cycle is going to go from negative pi over 4 to 3 pi over 4. How long is that? Is that 2 pi, 1 pi, 90 degrees, 45 degrees, it's whatever you can think of it in. How many degrees do I cover going from negative pi to 3 pi over 4?
No. 7.
How much? 180. So what is my period for this guy? Oh, is it my period pi?
Oh, you know what I did?
So doesn't that make sense? For one complete cycle there, is it going to take me pi to do that? And then I'm going to do it again, 2 pi to get 2 pi. Okay? No? Good? Okay.
Wait, but when you draw so, because I just moved it all over the floor.
Right, but sometimes it's not going to be as obvious. So, like I could throw 3 in there. I could throw pi over 4 and I could put a 3 in there. I could put a 1/2 in there. When I throw a 1/2 in there, it makes it a lot more difficult. So you're stretching. And the stretch always seems to be a little harder to see than everybody likes to shrink. Nobody likes to stretch. So again, set up your thing. But now since we're starting at pi over 4, just separate these into every 45 degrees. And yeah, you're right. You can start right here. You can shift it and start right here. This is your negative pi over 2. Here's your 0, your 1, your 0, your negative 1, your 0. And you're gonna do it again because you need 2 full cycles. Your 0, your 1, 0. Okay, and just keep on going with it. Okay, does it make sense to you? Okay. Basically, that's what I have for you. So today when you do some of those phase shifts,